name is Qingqiang Ren. I'm a PhD student from Xiamen University, China, and I'm studying in Professor Yang Chen's lab as a visiting PhD student. Very happy to be here to share my research with you. And my research is evaluating the performance of the limited management procedures in an ecosystem perspective, a case study for emergency procedure in the University of China. The first part is the introduction and background. And as we can see from this picture, the exploited stocks within the biologically sustainable level has been decreasing in the past several decades. And China is the biggest capture producer in the world, and its production is almost the combined production of Indonesia and Peru. And China is in its challenge to sustain the marine fisheries, and about 57% of the fish stocks were overexploited or collapsed. And the China's wild fish catch was mainly supported by a limited number of highly abundant fish stocks, and the remaining stocks are in decline or have collapsed, including the large yellow croaker stock. And in response to the overfishing and the steady degradation of the fishery resources, Chinese government has introduced a series of management measures to rebuild and protect the marine fisheries. These measures can be roughly divided into the input controls, the output controls, and technical limits, and they're mainly focused on the input controls related to the restriction of the input efforts, and the summer fishing moratoriums and releasing programs. But most measures were applied on all fish stocks, and the species-specific management measures were still lacking. And large yellow croaker is one of Chinese 4 main fisheries, and it has very, very high value, especially after it's collapsed. And its production is mainly from the East China Sea, which peaked in 1974 and declined over 19% by 1990s because the spawning and overweighting aggregation was heavily depleted. Then the stock was collapsed and has not recovered yet. The Minviva estuary is the biggest estuary in Fujian province, and it's also one of the most important feeding and breeding ground for large yellow croaker in the East China Sea. But this stock has not well assessed in the Minviva estuary and even in the East China Sea, so the stock was data limited. And in recent years, the high number and long-term releasing program has been conducted in the East China Sea, especially in the Fujian province, and the number of released large yellow croaker juveniles in the Minviva estuary reached from 1.9 million to 8.8 million. Now, when we talk about the releasing, the concept of the ecological carrying capacity, the ECC was frequently mentioned as the threshold of the maximum size of the target stock that can be supported by the ecosystem over a period of time with by the given environmental conditions. The stock can get the highest growth rate and MSY when the biomass was equal to the half ECC. But the ECC of large yellow croaker has not been assessed in the Minviva estuary and even in the East China Sea. So this stock is mainly facing these issues we just mentioned. So we want to identify the satisfactory management procedures for the large yellow croaker stock using some data limited methods based on the current status of the stock. And then we want to assess the ECC of large yellow croaker using a photo web model. And technically, we want to evaluate the ecosystem effects of the management procedures, because this part has been less evaluated. And finally, we can find out the optimal management procedures for the large yellow croaker stock. The second part is material and method. The data we used in this study was mainly from mainly collected using bottom trawls in Minviva estuary in 2019 and 2018, and for other functional groups, they are from the published literatures. And this is a flow path of MSE. I'm going to make it brief. So firstly, we need to set the performance metrics, which means we need to clearly define the management objectives, and we need to know what we want to achieve with these measures. And then we can identify the candidate management procedures, MPs, based on the data availability of the operating model, which includes stock and fleet dynamics, the collection of data, and the implementation of the measures. And after that, the satisfactory management procedures can be selected based on the threshold of performance metrics we set at the beginning. And the last step was the formal management procedure review. But in this study, we replaced it with the simulation of the effects of satisfactory MPs on the ecosystem. And then we can find out the optimal management measures for the large yellow croaker and in the context of the current management system. So we set 4 scenarios. For scenario 1, only the satisfactory MPs were applied, and for scenario 2, the combination of fishing moratorium and the satisfactory MPs were applied. And scenario 3 and 4 were just the scenarios 1 and 2 after the releasing. So the results, firstly, we can get the snapshot of the energy flow of the ecosystem based on using the EcoPath model. And based on the model, we can assess the ECC of large yellow croaker stock by gradually increasing its biomass until the balance of the ecosystem was broken. So the suggested biomass for releasing was the difference between the half ECC and the current biomass, and the suggested number was assessed based on the average size of released individuals, and the number was 1.6 million. And maybe you can still remember the number of released individuals into the Minviva estuary in the last 2 years was about 8.8 million. It's quite a big number. A total of 12 management procedures were alternative for the management evaluation, including 5 input controls and 7 output controls. And as we can see from these 2 pictures, the input controls had better performance in keeping the biomass and avoiding the overfishing. And we selected 4 performance metrics which related to the spawning biomass at the MSY level, the overfishing, and the yield. And the 5 candidate input controls will include 2 effort-based procedures, which were current fishing effort levels and 75% of current fishing effort levels, and 3 length-based procedures, which were related to the length of rotation. And all the candidate output controls were catch-based, which related to the attack and historical catch. And 4 MPs were fully met the performance criteria, including 3 length-based procedures and 1 effort-based procedures. But considering the data availability and the difficulty of the achievability, only the effort-based procedures were evaluated based on the photographs model. So, all 4 scenarios, the biomass of large yellow croaker increased significantly after the 10 years simulation and was almost stable after that. And the degree of the increase was relatively higher without the releasing, but the biomass was still lower than the half ECC. And the degree of increase were relatively lower after the releasing, but the biomass was higher than the half ECC, so no further releasing is necessary. And based on this result, we can see the combination of the satisfactory MP and the fishing moratoriums after the releasing has the best performance in recovering the large yellow croaker stock. So the take-home message was after we aggregated the MSE and ecosystem model together to evaluate the satisfactory, the effect of satisfactory MP on the ecosystem, and the combination of releasing, decrease in fishing effort and fishing moratorium was the optimal management measure for the recovery of large yellow croaker in the river estuary and in the context of current management system. I want to acknowledge our sponsors for giving us the fundings, and my supervisors, collaborators, and some of them you will meet later if you still stick around. And finally, I also want to thank my colleagues in fish biology laboratory in Xiamen University. Thank you for your time and teaching, and if you have any question, I would like